Okay, so let's take a look at some review of what we know about quadratics. Remember, there are three main forms that typically get used for quadratics. Three forms. So usually you list off standard form first, which is y equals, what is it, ax squared plus bx plus c. And then we've got vertex form, which is y equals a x minus h all squared plus k. And then we've got, what's the other one? Oh, intercept form. And intercept form is y equals a parentheses x minus p, x minus q, where q and p are your x-intercepts, if they exist anyway. So those are the three forms. We've used those a lot. And what I want to do is a problem where we convert from one form to another. So the example I'm going to do here is use completing the square, I'm abbreviating here, to write this function f of x equals 3x squared plus 12x plus 11 in vertex form. So we're converting from standards of vertex. So let me rewrite the original problem, the original function. And typically when we complete the square, you want to deal not with 3x squared, but with 1x squared. So, and a lot of times that means you divide 3 over to the other side, but usually you have a 0 over here or a constant over there. I'm actually going to do everything all on this side. I'm going to leave f of x totally alone. So here's how I'm going to do it. I'm going to factor out a 3 from just the first two terms. So I'm going to get x squared plus 4x. And then over here, plus 11. Okay, so now the inside of the parentheses here is in the form that I want to complete the square. My b is 4. And remember, to complete the square, you take half of b and you square it. So it's x squared plus 4x plus half of b, right? So b over 2 squared. And then I've got plus 11. But remember, I just added in something. So if I want to keep this all value the same, if I want to keep the value the same as the previous step, whatever I added in, I have to subtract too. And then that'll keep everything exactly the same. Whoops. Okay. So the amount that I added in looks like it's 4 over 2 squared, but it's not really, because really what I added in was 3 times 4 over 2 squared. So I actually need to subtract that amount. And so this looks uglier than it needs to be, so let me simplify it a little bit. 4x squared plus 2 squared plus 11 minus 3 times 2 squared. Okay, and the reason I left the 2 there was because this is going to turn into x plus 2 all squared. That's the completing the square part. Plus, and then this is 11 minus 12, so minus 1. And if you look at it, we're done. It is, whoops, it is now in vertex form. So I can now say, oh, look, my vertex is at -2, -1. It opens upwards because a is greater than 0, which is 3. Right? You could graph it just by plotting a few points, but the key point here is the vertex. So what I want to do now is do this a slightly different way. So not completing the square. Another way. So f of x, again, the original was 3x squared plus 12x plus 11. Now if you remember the quadratic formula, it's -b plus or minus some square root all over 2a. Well, if I take the average of those two things, right, these tell me where it crosses the axis. Right? If I take the average of it, I get the x value right in the middle, which is the vertex. So the x-coordinate of the vertex, the average of -b plus something over 2a and -b minus something over 2a is -b over 2a. So the x-coordinate of my vertex is -b over 2a. -b is -12, and 2a is 2 times 3. So my x-coordinate is going to be -2. So now I have the x-coordinate. The way to get the y-coordinate is just to plug that back in. So really, it's f of negative 2, which is 3 times negative 2 squared plus 12 times negative 2 plus 11, which ends up being negative 1. So now I know my vertex is at negative 2, negative 1. Let me erase this because I don't actually know if that's what the thing looks like. So vertex is at negative 2, negative 1, and I know that in vertex form, it's going to be a x minus the x coordinate of the vertex, which is negative 2, so this turns into plus 2 squared, plus k, which is minus 1. And then the way to get the a, well, it's the same a as it originally was, 3. There's a 3, and we're done. Okay? If you watch the next video, that'll be on graphing more complicated looking polynomials. Quadratics are pretty easy. You plot the vertex, plot another point, and use symmetry. So if you miss class on either Friday or Monday, depending on what period you're in, watch these 2 videos and you're all caught up.